Hey everybody, welcome back to another rambling, semi-coherent project update. I've been calling this Project No Ice for the reason that I'm sick of running to 7-Eleven for bags of ice when I go camping. So if you remember my last video, I replaced the 117 amp alternator, the factory one, with PA Performance 160 amp alternator. And I did the Jeep Cables Big 7 kit, wiring kit, which pretty much replaces the entire charging system harness with 2-gauge wire, big thick wire. Grounds also, big chunky ground wires. That is sort of the prelude to what I'm doing next. So yeah, in my quest to never buy ice again, I bought a portable 12 volt, 120 volt refrigerator. It's made by Arctic Ice. This is a 21 liter unit. It was a good price. I got it locally. I didn't have to pay for shipping. I was looking at refrigerators on Amazon, which, I found a lot of fairly priced ones, but the shipping to Taiwan is just insane. So I'm glad that I found this one. It came with a thermal jacket, which is, decent thickness. The finish is pretty nice. I haven't really put it to the test yet. I ran it on 120 for, I think, 14 hours at home, and everything was fine. It's fairly decent fridge. Comes with all the temperature recommendations on the inside of the lid. It runs quiet. It's got an LG compressor, so it's, for what I paid for it, I'm happy so far. We'll see how it goes. Now, obviously, I'm not going to power the refrigerator off of my starter battery, especially that one. What I'm going to do is build a battery bank. Now, I know these look small, but that's for two reasons. First off, I want to keep the Jeep fairly light, being that I have 35-inch tires. I have a big, heavy roof rack and 150 some odd pound rooftop tent. So I want to keep the Jeep fairly light when I'm climbing over the rocks and stuff to get to the good camping spots. And the second reason is that I want to stow these batteries in a place that doesn't take up valuable space. So my idea is to put them, well, I made these mock-up batteries to sort of play with different placements once I get the system set up. And being that these are AGM batteries, they're non-spillable, so you can sort of maneuver them however you want. I think in the instructions it says you just can't mount them upside down. Any other way is fine. So what I'm planning on doing is mounting them on their sides, positive, negative. I forgot to mention, these are twin batteries, except for one of them is reverse post, and that allows me to run them parallel and have the posts. If you see the posts here, I got positive, positive, negative, negative. So the part numbers, AGM 28MJA, and this one over here is AGM 28LA. So what I'm gonna do is set them up so I have positive, negative, and then on this one, negative, positive. And they'll go together like this. Unlike this setup, this is just so I'm doing a bench test. But with these, the positive is going to be opposite the positive over here, and that's just because of space requirements. Let me cut it here, and I'll put these mock-ups where they're going to go in the Jeep, and I'll show the location. Okay, so I have the mock-ups situated where the batteries, the real batteries, will eventually live. Now, if you have an unmodified TJ, you're not going to be able to do this. I kind of have a unique situation in that this is a TJ6, which means that if you've seen my earlier videos, you know that I cut the Jeep in half right here and stretched it back 15 centimeters. And so when I did that, that moved that entire rear deck back 15 inches, bench seat and everything. So in order to get my leg room situation close to where it was, I built custom seat brackets to move the seat forward. I believe it was 8 or 10 inches. I can double check that, but I think it was 10 inches actually. And so that leaves me with these handy little cubby holes underneath my seat, not unlike my old Vanagon had back in the day. So it's a perfect spot for the batteries. If you look, they fit flush underneath, so they're not taking up any valuable space. And if it turns out, when I do my bench test, if it turns out that 2 AGM batteries aren't enough, the 56 amp hours that I have now aren't enough to last me until, comfortably into the next afternoon, then I have room on the driver's side to put 2 more AGM batteries, and link all 4 in parallel, and that'll be more than enough power. So the beauty of having the batteries underneath the seat is that they're going to be really close to where the refrigerator is going to be located in the rear. The fridge is going to live somewhere around here in this spot here. I'm working on developing some sort of, I know a lot of guys use those drawers that, the sliders to pull their fridges out, but I don't really, that's really not a good option for me because of the size restrictions. I'm thinking that I can develop something. If you know what Vanagon tables had back in the day, they had sort of a swivel arm that would swivel out away from the wall. And I'm thinking of doing something like that, developing some sort of arm that swivels so I can literally just swivel the fridge out so it's somewhere out here like this. But back to the batteries, being that the batteries are underneath this seat, the path that the power wires are going to have to run from the batteries to the refrigerator is going to be really short. So I'm not going to have to worry about voltage drop. Okay, so back to the topic of battery size. Being that these are small batteries, 28 amp hours a piece, 56 together when they're paralleled, I was not sure if that was going to be enough. And I'm still not sure if that's going to be enough to run my fridge. What I'm looking for is, maybe an evening arrival at the campsite and, power to the fridge until, comfortably into the next afternoon. That's pretty much my goal. So I wasn't sure if I was going to get that out of these 2 batteries. So I went on the web forums, Facebook, Jeep forum, and a few overland forums and posted questions. And as usual, the results are all over the place. Some guys are saying that this is way too small. There's no way I'm going to be able to make these 2 batteries power that fridge for any significant amount of time. And then other guys are saying that, they actually use these 2 exact same batteries, and one they use for a starter and the other they use for an auxiliary. So, who knew what the actual deal was? So in order to figure out for myself, I decided to just do a bench test and see exactly how long these 2 batteries are able to power my refrigerator under moderate conditions. Right now it's in this garage, it's got to be, I don't know, maybe 70 between 70 and 75 degrees. I live in Taiwan, so it's nothing like the States right now. So what I did was I got a battery monitor, which comes with this mechanism here called a shunt. And this is supposed to be the most accurate way of sort of tracking your currents and what your load situation and your charge situation is at any given point. So I wired this monitor into the system and mocked up how the fridge would be, roughly how the fridge would be set up. I say roughly because I'm going to change some things about wire gauge and such. But so if you look at the monitor, I powered the refrigerator up in eco mode and set it to negative 18 degrees, that's Celsius. Negative 18 Celsius, which is what you need to keep meats fresh and fish and stuff. And so I powered that on about 4.5 to 5 hours ago. And so far, this is telling me that I still have 22 hours and 10 minutes worth of battery life before these two batteries drop to the cutoff point that I have set, which I think it was 11.5 volts. So I think that according to that, if that's right, then I should be okay with just these two batteries. And I should even be able to run maybe a small fan and charge some cell phones and stuff off of these two batteries and still be okay. I'm going to leave this running. I'm going to leave the fridge running overnight and see where I'm at in the morning. But if I'm still 10 hours from now or so, if I'm still reading in line with this 2210, minus 10 hours, obviously, then I'm gonna call it quits with just the two AGMs, because there's no sense in adding extra weight to the Jeep if I don't need to. Morning, everybody. It's just over 17 hours since I powered on the fridge on my paralleled AGMs. As it stands, I'm at 35 amp hours. The fridge is drawing 2.27 amps. It just kicked back on. It'll get down to negative 16, or get up to negative 16, and then it'll kick back on to get it back down to negative 18, where I have it set. I got 12.2 volts on the meter. On the fridge itself, I'm at negative 16. It just kicked on again, like I said. When it kicks on, the fridge reads 11.5, between 5 and 6 volts. I'm assuming that that's voltage drop because the wire is so long, the power wire to the fridge is so long. So that's something that I'm going to fix in the final installation. All right, so I'm going to close this video out by just quickly talking about what my installation game plan is. I've disconnected the fridge and shut it off, and I'm charging the batteries up again now. One cool thing I noticed about the Renogy meter monitor is that when you're drawing power, these two arrows point down, and when you're charging, they point up to let you know, and the screen blinks. So it's pretty cool. So I'm using a Naco Genius 5 to recharge the batteries. And they're charging at 4.9 amps, just for reference sake. So my game plan is that when I install these batteries, as I said before, I'm gonna flip them on their side and mirror them and link them together using 4-gauge wire for the negative and the positive. And then from the negative, I'm gonna come off into the batteries will go underneath my rear bench. And next to the bench, or next to the batteries on my transmission tunnel, I'm gonna mount my shunt. And from the shunt, I'm gonna come off the load side with approximately 2 to 3 inches of 4-gauge wire into a negative bus bar. And from the negative bus bar, I'm going to use 10 gauge as opposed to the 16. A short run of 10 gauge, just short enough to get a 12-volt adapter plug wired into the system. And then from there, I'll just run the 16 gauge plug adapter from that came with the fridge. And that should be it for this project. I'll be able to, with the readings that I got, I know that I'm going to have enough power left over to run some other accessories off of the bus bar, the negative bus bar. So I'll be able to get a reading of the fridge and all the other accessories, how much amperage I'm drawing and where I'm at, how much time I have. So I'll wire those other accessories into the bus bar, so the shunt will pick those up too. But as it stands, I'm going to wrap this video up, and I'll post back another video after my first real camp out, and hopefully everything goes good. Stay tuned.